Alright, so to get started with the welding symbols, let's take a look at some example blueprints. And what we have right here is basically an enlarged view of this particular zone on a set of plans where weld symbols are included. So let's take a look at a couple of specific details associated with this. So first of all, we had a drawing that actually included an enlarged view of a part, or a breakout view. And we're used to our normal title block. That's there. Let's see if I can change this thing down a little bit. There we go. We got our typical title block. It's right here. We'll change that just a hair more. And we have our standard information associated with it, material, tolerances, who did it, that kind of thing. We even have some specific notes. So these are actually our instructions are associated with the print. We would refer to these as local notes because they don't deal with anything more than what's on this page. Actually, paint specification there. We have our typical views of parts, and then we start to see things like our normal object lines, which we see there. We're used to that, and we see in our hidden lines there, our center lines. We're seeing dimensions, but then we start to see this right here, and this right here, and this right here. This random leader that comes out and has some kind of little funky symbol attached to it. And we have some other things here, of course, like I said, dimension lines and that sort of thing, but these are new to us, so these are actually standing out in terms of what are these. And that is essentially our purpose in this lecture, is to talk about what a person does when they see this information on here. Now, of course, these are welding symbols. You may have already seen them. This may be your first time. Who knows? But this is the starting point. You recognize them on the drawing, and your first thought process is, well, what am I actually looking at here, and what's the game plan associated with this? So, for example, a welding symbol is usually going to be attached where there's more than one part involved. For example, you have to have two parts to actually weld something. You just don't weld something just for the heck of it, typically. So you'll notice right off the bat that we're dealing with a part here, and we're dealing with a part here. And the point of contact between these two, or what we refer to as a joint, is at this zone, and you'll notice that there is a weld, some type of weld applied here and here. The same is true down here. So before we get into the weld symbols, it's always important when you're looking at a set of plans to notice what you're dealing with and what the bigger story is first, before you try necessarily just to fire in and figure out what you're going to weld. Pay attention to the rest of the prints to understand what's happening to begin with. Alright? Alright. Now, a weld symbol can be more than just a symbol. Now, we're going to get used to this right here, this overall shape. But a weld symbol can be more than just the arrow and the tail. It's going to also, can sometimes also include information on the tail section, letters, for example, SMAW, for specification processes. So a weld symbol is going to be more than just a graphic representation. It's going to have some specifications too. Let's take a look. This, for example, kind of helps drive it home for us a little bit. If I can get this to zoom in a little bit better, we'll see here. There we go. So here we have a welding process, and what we're seeing is essentially get my sketcher out here. What we're actually seeing is the representation of a part with a little bit of extra information, a little bit of written information, and a sort of a physical description or a picture image of what's actually happened. So in the overall story, we're going to be looking at the symbology, we're going to be looking at any extra information regarding specification, and we're going to be looking at what's actually physically going on. Now, while we're here, let's talk about what we see here on our right. Before a part actually gets pieced together, as I mentioned previously, you have to have more than one part to actually do some welding typically. So for example, if I were going to take this plate with a cylinder on it, and this was what it would look like on a set of plans, I'm actually creating, by placing this cylinder on top of this plate and pushing it down into where it's resting on it, I am creating a joint or a mating point between two parts, two features, that sort of thing. And this joint is essentially what drives us in terms of welding. For example, we have to have joints really to have welds. And there are essentially 5 basic weld joints that we're going to deal with. And this is basically the way that you attach 2 pieces together prior to the weld. So let's take a look at some of these. First off, we have something called a butt joint, a lap joint, edge, a T-joint, a corner joint. And that makes sense. For example, in all these cases, let's say this is part A and this is part B. These parts are mated together in some way. And in the butt joint, they're butting up together. In this case, A is overlapping B. A is running into B to create a T-joint. We basically have A and B sort of laying on top of each other for an edge. And then we got a corner joint, which is a T-joint, except it's not on the T, it's perpendicular still, but it's on the edge of the part to create, therefore, a corner. So these are the conditions first that are established before the weld begins. Is what type of joint do you have, and then that will drive what type of weld you might perform. Alright, so let's take a look first at the butt joint. So in a butt joint, as mentioned, you essentially have the 2 pieces sharing a surface together. Makes sense. And for reference, a butt joint can be welded with or without edge preparation. And the materials don't have to be the exact same thickness. For example, this one could be a 1/2 inch and this one could be a 1/4 inch thick, and you could still accomplish a butt joint. It might change a little bit, but it can still be done. Depending on, typically you already have one edge or at least one surface that are basically smooth across one or the other. Butt joints are commonly used in sub-assemblies and during fabrication and repair operations. So it's very common to see a butt joint called out on a set of plans. Now while we're here, let's take a look at the lap joint. Lap joint, as you can imagine, is the overlap of one material of the other. Technically, it is stronger than a butt joint because it essentially creates a thicker material in certain zones. And so a stronger component can result from a lap joint. Lap joints are commonly welded on both sides. So for example, there would be weld here and there would be weld here. So resulting in a very, very strong connection. Lap joints are typically used more for repair operations or extensions. They're not as a fabrication level type of weld. You're more used to these in the field and retrofitting type of applications. Now, a very common and desirable type of joint is the T-joint. So a T-joint, as you can imagine, is 90 degrees from one part to the other. For example, if we were to put a square right here, we should be reading about 90 degrees between one surface and the other. It is ideal that we get to weld on both sides of this particular joint to increase strength. It can be very strong, and you see a T-joint type of weld used in a lot of fabrication applications, especially structural, because in building, construction, that kind of thing, we have a lot of members where forces are transferred from vertical to horizontal and vice versa. So we use a lot of perpendicular weld connections to transfer such loads. So this might resist friction, this might resist down, you never know. So a T-joint is one where very common that you will run across a lot. And you'll find that obviously is used a lot with a fillet weld. Our next one is the edge joint. Button, there we go. Now obviously in an edge joint, members are sort of parallel with each other. There can be some overlap, but there typically needs to be almost a parallel nature to actually get the edge to work. They're used typically to join straight and flanged members. They can actually be used for creating stronger material, for example reinforcement in certain zones or weak zones. For example, if this part had a weak zone in here, by welding it or by using the edge joint connection, I can add strength and transfer some of that force and stress to the other member so it's not concentrated on this one. You will see edge joints in a variety of different applications, so nothing necessarily repair or fabrication or assembly. It just depends on, you can see it a lot actually in repair because of the fact that it just adds strength when needed. All right. So I get this thing behave, and we'll finish up the joints with the good old-fashioned corner joint. Obviously, corner joint, you get the feel for it. Similar, of course, to the T-joint. Our ideal scenario still results in a 90-degree application. That's always good for us. The actual weld will typically occur on the outside of the joining members, and this is the kind of thing you see in tank or box welding, that kind of thing, where you don't do a lot of structural welding on the inside of the feature, you do on the outside. So this is your plane of work, and obviously a zone of stress that occurs in the parts too, especially if you think of like a tank situation like this. This is where you're going to get a lot of stress and where your corner joint's going to come into play. Alright, so that gives us the overall concept of the type of situations where we're going to weld. We haven't really even talked about yet what welding is. So we've got to do that next. But before you get started with the welding processes and all that entails, you just have to look at the drawings to figure out what type of joint situation you're in, and then what relays off that, because sometimes some welds don't make sense on plans in terms of the type of joint you're already dealing with. So you got to know this first before you go into the next stuff. That's a good stopping point for now. 10 or 11 minutes is always good for learning. We'll take a little quick break and pick up on the next one. We'll see you.